Okay, we're going to keep practicing converting polar and rectangular equations. Last time we converted coordinate points. Now we're going to convert equations. They're the same things to remember. Rectangular form variables, you always want x and y. Polar form, we want r and theta. Facts to remember, you've always got to remember x equals r cosine theta, y is r sine theta, x squared plus y squared equals r squared. Okay, convert the rectangular equations into polar form. Okay, polar form, I'm actually looking for an equation that says r equals or r squared equals. Most of our cases we're looking for an r equals. Okay, so I've got to substitute. I know my y stood for r sine theta. My x stood for r cosine theta, and this is squared. I'm going to bring that square in. You can bring it in over multiplication, not addition or subtraction. So you take that r sine theta equals r squared times cosine squared theta. Okay, I'm trying to get r. I've got r's on both sides, so I'm going to divide both sides by r. I can eliminate one of them. Now I have sine theta equals r cosine squared theta. Getting r by itself, I've got to divide by cosine squared. So r is going to equal sine theta over cosine squared theta. Sometimes the book will go ahead and simplify. Remember that a sine over cosine is a tangent. So this would be a tangent theta. That would leave me with a cosine on bottom, which would be secant theta. Okay, we've got x equals 4. You've got to remember what x stands for. X is that r cosine theta equals 4. Get r by itself. R equals 4 over cosine theta. Same would be 4 secant theta. X squared plus y squared equals 16. I'm going to make two substitute. Well, actually, remember you're looking for r. You have an equation that says x squared plus y squared equals r squared. R squared equals 16 means r equals 4. Easy peasy. You could have gone the long way around it. R cosine theta squared plus r sine theta squared. R squared cosine squared theta, r squared sine squared theta. Factor out that r squared, cosine squared theta plus sine squared theta. We know sine squared plus cosine squared equals 1. So this would just leave me with r squared equals 16, which is exactly where we were, equals 4. All right, more substitutions, converting rectangular equations into polar form. 3 times r cosine theta plus 5 times r sine theta minus 2 equals 0. 3, actually what I'm going to do is take an r out. Since you want to solve for r, you want to try to only have one r if you can. So what I'm going to do is factor out the r. That's going to leave me with 3 cosine theta plus 5 sine theta. Let's go ahead and move the 2 over. We add the 2, so that equals 2. Now r equals 2 over 3 cosine theta plus 5 sine theta. Convert the polar equations into rectangular form. R, okay? If I want rectangular form, I want x's and y's. We know r squared equals x squared plus y squared. In order to get to that, we would have to square both sides and then make the substitution. If I'm squaring both sides, I'm going to have r squared equals 4. which means I'm going to have x squared plus y squared equals 4. Graphing wise, this is a pretty easy one to graph. If r equals 2, I want a circle with radius 2. This one has my center at 0, 0, radius of 2. Just from your conic sections, you should be able to easily check these. Okay, convert into rectangular form. This time they only give me an angle. We know where it's at, but now I need an equation for that. We know that if that's pi over 4, we're just looking for the equation of this line. Slope, since that's pi over 4, my slope would be rise over run, 1 over 1. Y equals mx plus b. So y equals my slope of 1, x, plus my y-intercept of 0. So y equals x. R equals cosecant x. Okay, if I get that equal, well, I'm looking for something that I can substitute. I know x equals r cosine theta, and I know y equals r sine theta. If I can rearrange my equation to get something that looks like this, I could replace it with an x. Or something that looks like this, I could replace it with a y. So what I'm going to do is I'm going to rearrange this. I'm going to divide by cosecant theta. So r over cosecant theta equals, if I divide both sides by cosecant theta, this equals 1. This would be the same as r times sine of theta with cosecant on the bottom equals 1. And then we know that r sine theta is y equals 1. Okay, changing this one to rectangular form. Remember, we have x squared plus y squared equals r squared. Well, we have r, and so in order to make it r squared, I could square both sides, but then I'm not going to have any substitutions for cosine squared, because remember, x equals r cosine theta, not cosine squared. The other way to get an r squared without squaring both sides is multiplying both sides by r. So now I have r squared equals 3 times r times cosine theta. I know this is x squared plus y squared equals 3 times x if I make this substitution. So then I have x squared plus y squared minus 3x equals 0. You don't necessarily have to have it equal to 0, but some of your answers are probably going to be checking-wise equal to 0. Okay, one more problem. We've got a denominator. Let's multiply that over by r. You may not think you know what to do now, but it comes with practice. I'm just showing you some of the ways. If I distribute that, I'm going to have r plus r sine theta equals 2. All right, so I can change that to y. I've got that taken care of. Okay, if I get r by itself, r equals 2 minus y. I need that r squared again. Okay, this time I'm gonna square both sides. The difference is if I multiplied by r on both sides, I'd be creating another problem on the right side when I'm trying to fix this problem on the left side. So if I do that, r squared equals 4 minus 4y plus y squared. I'm foiling out. And then I can replace that r squared with x squared plus y squared equals 4 minus 4y plus y squared. Subtract the y squares to combine like terms. Now I have x squared equals 4 minus 4y. If I got that equal to 0, x squared plus 4y minus 4 equals 0.